The cosmos is a silent, glittering ocean of islands. Yet some of those islands are not what they seem. Hidden in the vast blackness are galaxies that defy everything we know. Celestial bodies so strange and powerful, they unsettle the scientists who study them. These are not just empty voids. They are dark galaxies, colossal structures bound by a terrifying, invisible force. Today, we embark on a journey to 25 of these cosmic anomalies, from ghostly giants made of almost pure shadow to invisible halos that could dictate the fate of our universe. By the end, you will understand the profound mysteries that lurk in the darkness and why they challenge the very foundations of modern science. What if our Milky Way is surrounded by invisible, hungry neighbors? What if the universe is mostly a place we cannot see? This is a voyage into the 25 dark galaxies that scientists fear. What part of the unknown cosmos makes you the most curious? Our journey begins with a cosmic phantom, a galaxy that should not exist. Named Dragonfly 44, it floats in the constellation Coma Berenices, a wisp of starlight so faint it evaded detection for decades. This is no blazing spiral like our own. Imagine a galaxy stretched thin, its few stars scattered so widely they cast a ghostly, ethereal glow like dust motes caught in a sunbeam. Visually, it is a whisper against the dark, yet this whisper holds a terrifying secret. Measurements of its stars revealed they were moving far too quickly. According to the laws of gravity, such swift motion should have torn this fragile wisp apart, sending its stars flying into the void. The only explanation is an immense, unseen anchor. Dragonfly 44 possesses the mass of our entire Milky Way, a colossal gravitational footprint, but staggeringly, 99.99% of that mass is completely invisible. It is a ghostly giant made almost entirely of dark matter. This discovery sent shockwaves through astronomy. How does a galaxy with the weight of a titan possess the faint glow of a candle? It challenges every model of how galaxies are born and built, suggesting dark matter can form structures all on its own, cloaking them in near total darkness. We are left staring at a profound cosmic contradiction, a place where the map of visible reality bears almost no relation to the terrifying, invisible mass beneath. But if Dragonfly 44 is a ghostly giant, then Segue 1 is its ancient, primordial ancestor. Drifting near the edge of our own galactic neighborhood, this tiny dwarf galaxy is so faint it was discovered only by accident, hidden within the data streams of a star survey. It is a mere smudge of light containing only a few hundred ancient stars. To put that in perspective, our Milky Way contains hundreds of billions. Segue 1 is not just dim, it is practically a shadow. Its luminosity is so incredibly low that for every one star you can see, there are thousands of solar masses of material you cannot. This makes it one of the most dark matter-dominated objects ever found in the entire cosmos. It is a fossil, a relic preserved from the universe's infancy, a building block that never grew into a grand spiral. The stars within it are ancient, over 10 billion years old, composed almost entirely of hydrogen and helium, the pristine elements forged in the Big Bang. This tells a profound story. Segue 1 is a cosmic time capsule, a snapshot of conditions when the first galaxies were just beginning to coalesce from the dark matter scaffolding of the early universe. Its very existence and its extreme properties force a critical question. Is this what all galaxies looked like at the dawn of time, before stars lit up in great numbers? Even its motion is peculiar, moving at a velocity that suggests it is on a long, looping orbit around the Milky Way, perhaps being slowly torn apart by our galaxy's immense gravity. Studying this faint fossil is like reading the first page of a cosmic history book, a page written not in bright ink, but in the deep, enduring shadow of dark matter itself. Yet some shadows are not just heavy, they are violently active. Triangulum 2 is another faint satellite of the Milky Way, a dwarf galaxy so small and dim it was only confirmed a few years ago. It appears as nothing more than a sparse sprinkling of ancient stars, a cosmic afterthought. But data from the Fermi Gamma Ray Space Telescope painted a far more menacing portrait. From the heart of this silent, star-poor galaxy, astronomers detected a surprising spike of gamma radiation, the most energetic light in the universe. This was not the gentle glow of starlight. This was the signature of something immensely powerful and destructive happening in the darkness. The leading and most thrilling explanation is that Triangulum 2 could be a silent killer, a place where dark matter particles are annihilating each other. According to some theories, when two dark matter particles collide in regions of extremely high density, they could obliterate one another in a burst of pure energy, producing the very gamma rays we see. The core of this tiny galaxy, packed with dark matter, would be the perfect furnace for such a reaction. The fear and fascination this inspires is profound. It suggests dark matter is not just a passive, invisible scaffold. It could have a dynamic, even self-destructive nature, a hidden physics playing out in the voids of space. But science demands caution. The debate is fierce. Could this gamma ray signal simply come from a collection of pulsars, the spinning corpses of dead stars, which also emit powerful beams of radiation? Distinguishing between these possibilities is incredibly difficult at such vast distances. This is the heart of the scientific fear. Triangulum 2 represents a tantalizing, frustrating clue. It might be the first direct evidence of dark matter's explosive interactions, a window into a hidden realm of particle physics. Or it might be a cosmic mirage, a trick of more ordinary stellar phenomena. The possibility that we are glimpsing the destructive side of the universe's dominant substance is what keeps astronomers staring into this particular patch of silence, hoping the darkness will finally speak. The search for these cosmic phantoms often feels like listening for whispers in a hurricane, but sometimes the whisper is so faint, its presence is only betrayed by the ripples it leaves behind. This brings us to Antlia 2, a galaxy so stealthy it was hiding in plain sight, a mere stone's throw from our own Milky Way. Discovered only in 2018, Antlia 2 is a lesson in cosmic camouflage. It is a dwarf galaxy, a satellite of our own, but it defies every expectation of what such a galaxy should look like. For its size, it is shockingly dim. Its stars spread so thinly across an immense volume of space that it has one of the lowest surface brightnesses ever recorded. If you could see it with the naked eye, it would appear as a faint, ghostly smudge larger than the full moon, yet containing only a fraction of the stars. It is a cosmic wisp, a galaxy of almost nothing, yet this wisp possesses a hidden strength. Astronomers studying the outer fringes of the Milky Way's gaseous disk found something peculiar. That disk, a vast reservoir of hydrogen gas, showed distinct signs of disturbance, a kind of gravitational ripple. Something massive had recently passed through it, like a ship leaving a wake in calm water. The prime suspect, the seemingly insignificant Antlia 2, the math was startling. To create such a pronounced disturbance, this faint, diffuse galaxy had to be far more massive than its starlight suggested. It was punching far above its weight. The inescapable conclusion was that Antlia 2 is enveloped in a colossal, invisible cloak of dark matter, a halo so massive it accounts for the vast majority of the galaxy's total heft. This stealth satellite, almost invisible to our telescopes, revealed itself through its gravitational footprint, a ghost that announced its presence not by shining, but by the shadow it cast upon the waters of our own galaxy. The enigma of dark matter is not confined to ghostly giants and stealthy satellites. Some of these cosmic shadows defy logic not by their hidden mass but by their apparent lack of it. Enter Crater 2, a paradox of scale and substance. Orbiting our Milky Way, this satellite holds a contradictory title. It is the fourth largest galaxy in our local group by physical size, a true colossus spanning over 7,000 light-years across. Yet, despite its grand dimensions, it is one of the absolute faintest objects we have ever detected. Its stars are scattered so thinly, with such immense distances between them, that the galaxy emits a feeble, ghostly glow. Astronomers call it the feeble giant, a sprawling ghost town in the cosmos. This presents a profound puzzle. A structure so large and physically diffuse should be incredibly fragile. The gravitational tides from the mighty Milky Way, which have shredded and absorbed countless smaller galaxies, should have torn Crater 2 apart long ago. Its stars should have been scattered into the galactic halo, dissolving its identity. The fact that it remains intact, a coherent though faint entity, suggests it must possess some kind of stabilizing anchor, a hidden mass holding it together against the tidal forces. Yet, when scientists measured the motions of its stars to weigh it, the results were baffling. Unlike Dragonfly 44 or Antlion 2, Crater 2 does not appear to be dominated by a massive dark matter cloak. Its stars move relatively slowly, indicating a surprisingly low total mass for its enormous size. This contradiction is what scientists fear. How can something so large and so feeble survive? If it lacks the protective gravitational shield of dark matter, our models of galaxy formation and destruction are missing a crucial piece. Perhaps its dark matter was stripped away in a past encounter, leaving a pale, expanded skeleton. Or maybe our understanding of gravity itself needs revision in these extreme, low-density environments. Crater 2 stands as a silent challenge, a feeble giant whose very existence whispers that we still do not fully understand the rules of the cosmic arena. The feeble giant Crater 2 presents a puzzle of survival, but another galaxy delivered a shock that threatened to unravel the entire dark matter paradigm itself. Meet NGC 1052DF2, a discovery that sent tremors through the world of astrophysics. This ultra-diffuse galaxy, similar in size to the Milky Way but containing only 1% of its stars, should have been another classic dark matter monster. Its sparse stars were moving too slowly. When astronomers calculated the mass needed to hold those stars in orbit, they got a number that matched almost exactly the mass of the visible stars themselves. There was no room left for dark matter. The result was so startling, so heretical, that the research team checked and rechecked their data for over a year before daring to publish. They had found a galaxy that appeared to have none of the invisible glue that supposedly holds the universe together. The anomalies did not stop there. Orbiting this strange galaxy were a collection of globular clusters, but these were not ordinary. They were 10 times brighter than typical globular clusters, shining with an almost arrogant luminosity against the faint background of their parent galaxy. It was as if the galaxy had poured all its remaining brilliance into these compact stellar jewels. The discovery of NGC 1052DF2 ignited a firestorm of debate. If dark matter is the essential scaffold for all galaxies, how did this one form without it? Was it a cosmic fluke, a galaxy that had its dark matter stripped away in a violent encounter? Or, more frighteningly, did it prove that dark matter is not an inseparable part of a galaxy, but a component that can be added or removed, challenging the very bedrock of modern cosmology? The fear was not about the galaxy itself, but about what it meant for our understanding. If one pillar of our cosmic model could be so easily toppled by a single, strange object, how many other fundamental truths might be waiting to fall? The shock of NGC 1052DF2 was not an isolated event. Its sibling, NGC 1052DF4, soon delivered a confirmatory crisis. This ultra-diffuse galaxy, found in the same region of space, presented astronomers with an almost identical and deeply unsettling profile. Like its counterpart, DF4 appeared ghostly and star-poor, a wispy patch of cosmic light. When researchers turned their most powerful telescopes toward it, measuring the motions of its own 10 globular clusters, they found the same baffling result. The clusters were moving with a languid, leisurely pace. There was no sign of the frantic orbital speeds that would betray the presence of a massive, unseen dark matter halo holding everything together. The visible stars and clusters alone accounted for nearly all the galaxy's measured mass. The finding was a brutal 1-2 punch. One galaxy lacking dark matter could perhaps be dismissed as a freak accident, a cosmic outlier. But two found together suggested a pattern. It hinted at a new, terrifying class of objects, galaxies born or stripped into a state of pure visibility. The scientific tension became palpable. If these galaxies are real and not some colossal measurement error, then our entire model of how galaxies form faces a drastic rewrite. For decades, the standard story has been clear. First, vast halos of dark matter condense from the primordial soup of the universe. Then, ordinary gas is drawn into these gravitational wells, cools, and eventually forms stars, giving birth to the galaxies we see. The dark matter is the essential foundation, the invisible skeleton upon which the luminous flesh of stars is hung. DF2 and DF4 threaten to pull that skeleton out entirely. How could these large, coherent structures exist without their foundational core? The fear was not of the galaxies themselves, but of the conceptual abyss they pointed toward. It forced astronomers to consider frightening alternatives. Perhaps these galaxies did form with dark matter, but some violent event, a high-speed collision with another massive body, ripped the invisible component away, leaving only the visible stars behind, drifting like debris after an explosion. Or more radically, perhaps our understanding of gravity itself behaves differently in these immense, low-density environments, mimicking the effects of missing mass without any dark matter at all. Each possibility unravels a different thread in the tapestry of modern cosmology. The confirmatory crisis of DF4 cemented a profound truth. These were not mere curiosities. They were direct challenges, silent ghosts demanding we question everything we thought we knew about the architecture of the cosmos. The profound challenge of the dark matter-deficient galaxies did not remain an isolated mystery in the quiet cosmic backwaters. Astronomers soon found the phenomenon occurring on a terrifying industrial scale, deep within one of the universe's most violent neighborhoods. The Coma Cluster is a monstrous metropolis of galaxies, a dense swarm of over 1,000 galaxies bound together by gravity, all swirling in a seething hot plasma that reaches millions of degrees. It is a place of extreme forces and relentless collisions. And there, within this cosmic pressure cooker, researchers made a staggering discovery. They identified not one or two, but 47 ultra-diffuse galaxies, each as large as the Milky Way but glowing with only a faint ghost light. The shocking part, measurements suggested that many, perhaps most of these galaxies appeared to be missing their dark matter halos entirely. The environment provides a grim, logical explanation, one that carries its own disturbing implication. Scientists call it harassment. This is not a brief, catastrophic collision, but a slow, grinding torment. As these fragile, diffuse galaxies orbit through the crowded cluster, they do not slam directly into others. Instead, they are constantly buffeted by the combined gravitational pull of every other galaxy and the immense cloud of hot gas they pass through. It is like wading through a relentless, powerful tide. Over billions of years, this perpetual harassment acts like cosmic sandblasting. The weak gravitational grip these galaxies have on their own dark matter is no match for the cluster's collective might. The invisible halo is gradually peeled away, stripped particle by particle, and scattered into the general pool of the cluster's dark matter. What remains is the luminous wreckage, the stars that were held most tightly, now left adrift as a faint, expanded shadow of their former selves. This is the core of the scientific fear. The Coma Cluster discovery suggests that dark matter is not an inseparable, permanent part of a galaxy's identity. It can be removed. The invisible glue that holds the cosmos together is not always a permanent bond. This forces a terrifying rethink of galactic life cycles. If dark matter can be stripped so efficiently in dense environments, then countless galaxies across the universe may have undergone similar transformations, their true natures hidden beneath a history of violence. We are left to wonder how many of the faint, ghostly galaxies we see are not primordial relics, but the stripped and plundered survivors of cosmic warfare. The harassment theory offers an explanation, but it deepens the mystery. It means that to understand a galaxy's present, we must first decipher its violent past, a past written in the absence of the very substance we are trying to study. The slow, grinding harassment of galaxies in the Coma Cluster shows us dark matter can be stolen, but what about a time before it was ever clothed in stars? To answer that, we must journey back to the cosmic dawn, to an era so ancient it defies comprehension. Here we find not faint ghosts of missing mass, but radiant, terrifying enigmas. Among them is an object named Himiko, a colossal beacon shining from when the universe was a mere 800 million years old. Discovered in 2009, Himiko is not a galaxy of stars. It is a giant, chaotic blob of glowing gas, spanning a staggering 55,000 light-years across. It blazes with a specific, telltale wavelength of ultraviolet light known as Lyman alpha radiation, the signature of primordial hydrogen gas being energized by something immensely powerful. The sheer scale of Himiko was immediately frightening. It was the largest object ever found from that primordial epoch, a glowing titan in the infant cosmos. But what was causing the glow? The terrifying possibility is that we are witnessing a dark galaxy in its rawest, most primal state. Himiko could be a vast, pristine halo of dark matter, one that has just begun to pull in enormous clouds of hydrogen gas. Within those clouds, the first furious generations of stars may be igniting, but they are hidden from our view, shrouded by the very gas they are trying to illuminate. Their intense radiation pumps energy into the surrounding hydrogen, causing the entire gargantuan cloud to fluoresce like a cosmic neon sign. We are not seeing the stars themselves, but their terrifying birth cries echoing through the fog of creation. Himiko represents a dark matter scaffold at the very moment it is being fleshed out, a snapshot of galactic genesis so violent and luminous it can be seen across 13 billion years. If Himiko was a shocking beacon, its successor, discovered 7 years later, was a cosmic heresy. Astronomers dubbed it CR7, and its light, emitted when the universe was only 800 million years old, carried a revelation that chilled theorists to the core. The spectrum of this brilliant blob showed something astonishing and deeply unsettling. It contained strong helium emission lines, but held almost no sign of carbon, oxygen, or any other heavy elements that are forged in stars and spread by supernova. This pattern suggested a terrifyingly pure environment. CR7 appeared to be a pocket of the primordial universe that had remained untouched by stellar pollution. The leading and most thrilling explanation is that CR7 is a dark galaxy caught in a singular, sacred act. It may be hosting the universe's very first generation of stars, known as population 3 stars. These are not like the stars of today, theorized to be monstrously huge, hundreds of times the mass of our Sun. They would have burned ferociously hot and bright, composed only of hydrogen and helium from the Big Bang. Their life would be spectacularly short, ending in cataclysmic explosions that would, for the first time, seed the cosmos with heavy elements. But in CR7, we might be seeing them before that pollution began. The fear and fascination here is existential. We could be staring directly at the first lights to ever flicker on in a dark matter halo, the pioneers that ended the cosmic dark ages. The implications are profound. If confirmed, CR7 is not just an ancient object, it is a living fossil of creation itself, a laboratory showing the conditions under which all future galaxies, including our Milky Way, would eventually form. It forces us to confront a chaotic, almost mythic era where the rules were being written in fire and light within invisible cages of dark matter. These luminous blobs are not peaceful nurseries. They are the violent, radiant birthplaces of reality as we know it, and their brilliant glow is a fearful glimpse into the first fragile moments of everything. The violent birth cries of the first stars fade into the deep past, leaving behind galaxies that must endure a brutal cosmic present. Survival in the modern universe often depends on an invisible shield, a lesson written in the faint light of a ghost drifting through a galactic battlefield. Deep within the Virgo cluster, a dense and turbulent gathering of over 1,000 galaxies, lies VCC 1287. This is an ultra-diffuse galaxy, a faint, wispy smudge of ancient starlight adrift in a sea of giants and searing hot plasma. To exist here is to live under constant threat. The gravitational tides from massive neighbors and the relentless pressure of intergalactic gas should shred a structure this fragile, scattering its stars into the void. Yet VCC 1287 persists. Its survival is not just puzzling, it is frightening. The clue lies in the very composition of its stars. When astronomers analyzed its faint glow, they found its metallicity to be extremely low. Metallicity in astronomy simply means the abundance of elements heavier than hydrogen and helium. These heavier elements, like carbon, oxygen, and iron, are forged in the hearts of stars and scattered by their explosive deaths. A low metallicity is a sign of great age, indicating that the stars formed long ago from pristine gas that had not yet been enriched by many generations of supernova. VCC 1287 is not just old, it is a relic that has been quietly drifting for billions of years. This presents a profound contradiction. How can something so ancient and so fragile survive in one of the most hostile environments in the local universe? The inescapable, chilling answer is that it must be cloaked in a massive, invisible shield. VCC 1287 is almost certainly enveloped in a vast, dense halo of dark matter. This unseen fortress provides the gravitational anchor, holding the galaxy's sparse stars together against the cluster's relentless forces. The fear it inspires is not of destruction but of resilience. It demonstrates with quiet power that dark matter is not just a theoretical concept, it is a practical, galactic-scale defense system. This faint ghost in Virgo is a testament to the enduring, hidden architecture of the cosmos, a silent survivor whose very existence proves the terrifying, protective strength of the dark. The silent, protective fortress of dark matter in Virgo raises a deeper, more unsettling possibility. What if the most perfect dark galaxy is one we cannot see at all? This brings us to a legendary cosmic ghost, a candidate so pure it sparked decades of debate. Known as HI 1225+01, this object is not a smudge of starlight. It is a vast, swirling cloud of cold, neutral hydrogen gas discovered drifting in the Virgo cluster. Its signature is a faint radio whisper, the telltale hum of hydrogen atoms. When astronomers mapped this whisper, they found something astonishing. The cloud was not static, it was rotating, spinning with the coherent, organized motion of a galaxy. A clear, distinct velocity gradient showed one side moving toward us, the other side moving away. This was the dynamic signature of a rotating disk, a fundamental characteristic of a spiral galaxy like our Milky Way. Yet, when they pointed every optical telescope they had at that exact spot in the sky, they saw nothing, no stars, no clusters, not a single pinpoint of light. It was a galaxy of pure gas spinning in perfect darkness. The discovery ignited immediate and fierce controversy. Was this finally it, the holy grail of dark matter research, a true dark galaxy? A pristine structure of dark matter that had gathered gas but for some mysterious reason had utterly failed to ignite star formation. It would be a cosmic stillbirth, a galaxy that never lived. The fear this possibility inspired was profound. It suggested there could be a hidden population of these starless structures, countless dark matter halos floating through the universe, complete with their own gaseous disks, forever silent and invisible. They would be the true ghosts of the cosmos, the dark matter universe made manifest, existing parallel to our own luminous reality, but science demands skepticism. The other, more mundane explanation was just as compelling. The Virgo cluster is a violent place full of gravitational interactions and collisions. HI 1225 plus 01 could simply be a massive fragment of tidal debris, a shred of gas ripped from a larger galaxy during a close encounter. This gas, flung into the void, could have been set spinning by the collision, mimicking the rotation of a true galaxy without any of the underlying dark matter structure. It would be a cosmic illusion, a brilliant piece of galactic wreckage masquerading as something more profound. The debate raged for years, a tug of war between two terrifying ideas. One implied a universe teeming with invisible, coherent structures, a shadow cosmos of failed galaxies. The other reinforced the chaotic, destructive nature of galaxy clusters, where even the debris can trick us. Follow-up observations have tilted the scale. Deeper searches have revealed a few, extremely faint dwarf galaxies possibly associated with the cloud, and the gas distribution appears more irregular than a pristine disk. The consensus now leans toward HI 1225 plus 01 being a spectacular tidal remnant, a beautiful and complex piece of wreckage, yet its legacy is permanent. It proved that a cloud of gas could perfectly mimic the signature of a dark galaxy, setting the standard for what such an object would look like. The fear it first generated is not gone, it is simply redirected. If this magnificent ghost is just debris, then the search for a true, starless dark galaxy becomes even harder. We are left wondering how many real ones might be out there, hiding in plain silence, their dark disks rotating forever in the endless night. The search for dark galaxies is not always a hunt for distant, silent phantoms. Sometimes the evidence comes screaming toward us at nearly 200 miles per second. High above the plane of our Milky Way, a colossal, ghostly structure is on a collision course with our home. This is the Smith Cloud, a massive streamer of hydrogen gas 11,000 light-years long and 2,500 light-years wide, containing enough material to build 2 million stars like our Sun. It is not a peaceful nebula. It is a high-velocity projectile hurtling directly toward the galactic disk. For decades, its origin was a profound mystery. Was it simply a clump of intergalactic gas falling in for the first time? Or was it something far more significant, a piece of our own galaxy's violent history returning home? Recent observations provided a startling clue. As the Smith Cloud plunges toward us, its leading edge is already beginning to interact with the Milky Way's outer halo. This interaction should be tearing the delicate cloud apart, shredding it with tidal forces and pressure from the thin galactic medium. Yet the cloud remains remarkably intact. It is holding its shape against forces that should have dissolved it long ago. The only plausible explanation is that this river of gas is not traveling alone. It is likely wrapped in a cocoon of dark matter, an invisible gravitational shield that is holding the cloud together on its fatal journey. This suggests a terrifying and beautiful story. The Smith Cloud may not be a random visitor. It could be the luminous wreckage of a dark matter dwarf galaxy that ventured too close to the Milky Way billions of years ago. In that ancient encounter, our galaxy's immense gravity would have stripped away the dwarf stars and gas, but its dark matter halo, being more diffuse and spread out, could have survived the ordeal. This invisible remnant, still clutching the shredded gas, was flung out on a long, looping orbit into the galactic hinterlands. Now, after completing a multi-billion-year journey, it is falling back in. The fear this inspires is not one of destruction, but of spectacular creation. Current projections suggest the Smith Cloud will plow into the Milky Way's disk in roughly 30 million years. When it does, the collision will compress the vast reservoir of hydrogen gas, triggering a fireworks display of star formation on a scale we rarely witness. It will be a cosmic renaissance, a burst of new stellar life ignited by the return of a ghost. We are witnessing a dark matter galaxy, or what remains of one, completing a tragic and beautiful cycle. It is a reminder that our galaxy is not a static island, but a dynamic, ever-changing ecosystem, still being shaped by the invisible skeletons of its past. Our own galaxy is not an island of light floating in empty space. It is the glittering heart of a vast, invisible empire. The stars we see in the night sky, the brilliant arms of the Milky Way, are just the luminous surface of something far deeper and more terrifying. Our home is embedded within a colossal, unseen structure, a dark matter halo so immense it defies easy comprehension. This is the invisible skeleton of the Milky Way, and mapping its contours has become one of astronomy's greatest detective stories. We cannot see this halo directly, so scientists must trace its shape by watching how it bends the paths of everything caught in its gravitational grip. They study the frantic orbits of tiny satellite galaxies like Segue 1 and emptier 2, whizzing around us at incredible speeds. They analyze the ghostly stellar streams, the stretched-out remnants of dwarf galaxies torn apart by our gravity, which now flow like celestial rivers through the galactic outskirts. Each of these trajectories is a clue, a data point in space that reveals the pull of the unseen mass. By combining thousands of these clues, a terrifying portrait emerges. The Milky Way's dark matter halo is not a smooth, featureless sphere. It is lumpy, extended, and profoundly asymmetrical. It stretches out for nearly 1 million light-years in all directions, a sphere of influence many times larger than the visible galaxy itself. Within this vast volume, the density of dark matter is not uniform. Current models suggest it should be filled with a churning sea of substructure, dense clumps and subhalos that orbit within the larger halo like invisible moons. This is where the scientific fear takes a deeply personal turn. We live inside this structure. Our solar system orbits within both the visible disk and this immense, invisible ocean. The potential existence of these dense dark matter clumps is not just a theoretical curiosity. A particularly massive, unseen clump passing through our region of the galaxy could gravitationally perturb the delicate dance of comets in the distant Oort cloud, sending a shower of icy bodies hurtling toward the inner solar system. It could subtly alter the long-term stability of planetary orbits over cosmic timescales. Even more chilling are the theoretical possibilities for exotic physics. Some models suggest the cores of the densest dark matter clumps could be places where particles annihilate, producing bursts of radiation or even strange, concentrated forms of energy we do not yet understand. Our galaxy's halo is not a peaceful, empty cloak. It is a dynamic, invisible ecosystem, and we are floating in its deepest, darkest waters, unaware of what unseen currents might shape our distant future. But the Milky Way's dark halo is not alone in the cosmic sea. Our closest galactic neighbor, the magnificent Andromeda Galaxy, holds its own immense and terrifying secret. Its spiral arms, a whirlpool of 1 trillion stars, are merely the visible embroidery on a cloak of shadow far larger than our own. For decades, astronomers have pieced together the profile of Andromeda's dark matter halo by watching its own retinue of satellite galaxies. These tiny, orbiting dwarfs move at velocities that betray a gravitational grip of staggering strength. The data paints a chilling portrait. Andromeda's dark matter halo is even more massive and extended than the Milky Way's, a vast, invisible sphere of influence that may already be brushing against the outermost tendrils of our own. This sets the stage for a collision of invisible worlds. In roughly 4.5 billion years, the Milky Way and Andromeda will begin their slow, inevitable merger. While artists' impressions show a beautiful celestial ballet of stars weaving through each other, the reality scientists fear is far more chaotic and profound. The stars themselves are so far apart that direct stellar collisions will be exceedingly rare. The real drama, the terrifying and unpredictable force, will be the interaction of the two giant dark matter halos. As these immense, invisible structures first graze and then plunge through one another, they will not simply pass like ghosts. Their gravitational fields will churn and slosh, creating violent tides and resonances. Think of it not as a clean collision, but as two vast, invisible oceans crashing together in slow motion. The chaotic waves and undercurrents generated will rewrite the gravitational rules for every star, planet, and cloud of gas in both galaxies. Solar systems could be flung from the galactic cores into the lonely darkness of intergalactic space. Others might be hurled toward the turbulent centers, where supermassive black holes will eventually dance and merge. The delicate spiral structures of both galaxies will be utterly erased, twisted into a new, elliptical form over a billion-year timescale. This is the core of the fear. We can model the broad strokes of this merger, but the precise, local consequences are impossible to predict. The fate of our own solar system hinges on the chaotic dance of the dark matter we cannot see. Will we be cast adrift or pulled into a brilliant, dangerous new core? The collision is a certainty, but our place in the resulting cosmic wreckage is written in the invisible currents of dark matter, a future we can foresee but cannot yet map. The fate of our galaxy is written in the invisible, but we needed undeniable proof that this unseen substance was real. That proof came not from a quiet, dark galaxy, but from a cosmic battlefield of unimaginable violence. 1.5 billion light-years away, two massive galaxy clusters, each containing hundreds of galaxies, slammed into one another at a speed of millions of miles per hour. This is the Bullet Cluster, and it provided the most direct visual evidence for dark matter ever captured. Here is how the terrifying evidence unfolded. When these titans collided, the different components of the clusters behaved in starkly different ways. The galaxies themselves, made of stars, are mostly empty space. Like swarms of bees passing through each other, they sailed right past one another with minimal interaction. The vast clouds of hot gas between the galaxies, however, are a different story. This normal matter, made of protons and electrons, interacts strongly. As the clusters merged, the gas clouds smashed together, compressed, and heated to staggering temperatures, creating a blistering barrier of X-ray emitting plasma that now lies between the two groups of galaxies. This separation was the key. Scientists then mapped the cluster's total mass using a phenomenon called gravitational lensing. This occurs when a massive object's gravity bends the fabric of space-time, acting like a lens to distort and magnify the light from more distant galaxies behind it. By meticulously measuring this distortion, astronomers could create a map of where the cluster's total mass actually was. The result was a revelation that chilled and thrilled the scientific world. The map of total mass, the dark matter, did not align with the searing hot gas. Instead, the two peaks of dark matter were located precisely where the two groups of galaxies now resided, having cleanly separated from the normal matter during the collision. It was a cosmic autopsy with a clear verdict. The dark matter, making up the vast majority of the mass, had simply passed through the collision unaffected, while the normal gas was left behind, slowed and shocked by the impact. This was the smoking gun. It proved dark matter is not just a theoretical fix. It is a physical substance that clumps and has mass, but one that does not interact with the electromagnetic force. It feels gravity, but not friction. The fear this evidence inspires is profound. While it conclusively proves dark matter exists, it also makes its true nature even more elusive and strange. The Bullet Cluster shows us that dark matter does not even interact with itself in any significant way. If it did, it would have shown signs of slowing down or clumping in the wake of the collision, just like the hot gas did. Its ghostly indifference is what terrifies physicists. It means dark matter particles are not just dark, they are almost perfectly slippery, passing through each other and through us without a trace. This perfect darkness solves one cosmic mystery while deepening another, leaving us with a universe dominated by a substance we can only witness by the silent, gravitational shadows it casts. Evidence of dark matter is written in the violence of colliding clusters, but our own galaxy hides a deeper, more intimate blind spot. Directly behind the dense plane of the Milky Way lies a region of profound cosmic silence known to astronomers as the zone of avoidance. This is not empty space, it is a curtain, a wall of obscuration built from billions of stars, swirling dust clouds, and glowing gas that constitute the brilliant disk of our home galaxy. To any optical telescope peering through it, the view is utterly blocked. It is as if we are standing in a brilliant, crowded city and trying to see what lies directly behind the brightest downtown skyscrapers. The visible light from distant galaxies is completely absorbed or scattered by this intervening murk, creating a broad band across the sky where traditional galaxy catalogs simply show nothing. This zone represents one of the last great unknowns in mapping our local universe. The fear it generates is not of emptiness but of hidden plenitude. What if, concealed behind this luminous veil, there are entire galaxies we have never seen? Not just ordinary spirals, but precisely the kind of ghostly, dark matter-dominated systems we have been searching for. Ultra-diffuse galaxies, with their incredibly low surface brightness, would be completely impossible to detect optically through such a thick screen. Even a relatively normal dwarf galaxy could be rendered invisible. This means our current census of the local group of galaxies and our understanding of the Milky Way's immediate gravitational neighborhood could be catastrophically incomplete. We have been mapping the cosmos with a glaring blindfold on. The possibility is deeply unsettling. A massive, nearby dark galaxy could be lurking just out of sight, its gravitational influence subtly tugging at the motions of the stars and satellite galaxies we can see without us ever knowing its true origin. Our models of local galactic dynamics would be built on missing information, like trying to predict the weather while ignoring a continent-sized storm system just over the horizon. To pierce this veil, astronomers must use other forms of light. Radio telescopes, which detect the faint emission from cold hydrogen gas, can peer through the dust. Infrared surveys can sometimes cut through the haze. These alternative views have already revealed a few tantalizing shadows, patches of structure that suggest hidden galaxies. Each candidate discovered in the zone of avoidance carries a double weight. It is not just a new galaxy, it is a reminder of how much we might still be missing. The greatest fear is that behind the Milky Way's dazzling core, there exists an entire hidden population of dark and dim galaxies, a secret assembly that could Chinese letter our tally of local matter and rewrite the story of our galactic neighborhood. The zone of avoidance is not a void, it is a locked door, and behind it the cosmos may be keeping its darkest secrets. The brilliant curtain of our own galaxy is not the only blind spot in the cosmos. To understand the true scale of our ignorance, we must pull back to a view of the universe itself. This brings us to the grandest dark structure of all, the cosmic web. This is not a metaphor, but the actual architecture of reality. After the Big Bang, subtle ripples in the density of dark matter were frozen into the expanding fabric of space. Over billions of years, gravity amplified those ripples, sculpting the dark matter into an immense, three-dimensional lattice. Picture a sponge on a scale so vast it contains all of existence. This sponge has dense knots where thousands of galaxies swarm, connected by long, slender filaments of dark matter, all surrounding enormous, empty voids. This is the cosmic web, and it is made almost entirely of the invisible substance we have been chasing. The luminous galaxies we see, from majestic spirals to faint dwarfs, are merely the glittering ornaments hanging on this dark skeleton. They form at the intersections and along the dense strands where the gravitational pull is strongest, gathering gas to spark star formation. But the fear lies in the spaces between the glitter. Those vast, stretching filaments of the cosmic web are not empty. They are rivers of pure dark matter, streams of shadow flowing between the bright galactic nodes. Within these rivers, the density of dark matter might be high enough to form its own structures, yet far too low to attract and hold onto significant amounts of gas. This is the terrifying possibility. Isolated dark galaxies, or even stranger, pure knots of dark matter with no stars or gas at all, could be drifting in these cosmic backwaters. They would be islands of shadow in a sea of deeper shadow, completely undetectable by any telescope that relies on light. Our entire map of the universe, painstakingly assembled from centuries of observations, is only a map of the streetlights. We have carefully charted every lamppost and glowing window in the cosmic city, but we remain almost completely blind to the roads, the bridges, the empty lots, and the hidden basements that make up 95% of the metropolis. These dark matter blobs in the filaments represent a hidden population of cosmic ghosts that could outnumber the galaxies we see. They are the true dark galaxies, so pure and isolated they may never reveal themselves through a flicker of starlight or a whisper of radio waves. Their existence is predicted by our most powerful supercomputer simulations of the universe, which show dark matter clumping at every scale, yet confirming it is a challenge that may be beyond our current generation of instruments. They are the ultimate expression of the dark universe, silent, sovereign, and forever just beyond the edge of our perception. The cosmic web is a prediction etched in light and shadow by our most powerful digital oracles. To understand the true population of dark galaxies, we must turn from the telescope to the supercomputer, where universes are born in lines of code. State-of-the-art cosmological simulations with names like Illustris TNG and EAGLE are our laboratories for the impossible. They begin with the primordial conditions of the Big Bang, seed the cosmos with dark matter, and let the relentless laws of physics play out over billions of virtual years. The results are breathtakingly beautiful and deeply unsettling. They consistently show that a galaxy like our Milky Way should be surrounded by a swirling cloud of not dozens, but thousands of dark matter subhalos. These are the dense knots and clumps within the larger galactic halo, the potential seeds for satellite galaxies. The simulations are clear. For every grand spiral we see, there should be a vast retinue of smaller luminous companions. But when we look up at the actual night sky, the numbers do not match. We see only a few dozen dwarf galaxies orbiting the Milky Way, not the predicted thousands. This glaring mismatch is known as the missing satellites problem, and it has haunted astrophysics for over 2 decades. It is a direct confrontation between our best theories and the reality we observe. The terrifying, elegant solution is that the simulations might be right and our eyes are wrong. What if the thousands of predicted subhalos are all out there, but the vast majority are almost completely dark? They are the true dark galaxies, halos of shadow that either never managed to attract enough gas to form stars, or had that gas stripped away so early in their history that they remain invisible fossils. This idea transforms the missing satellites problem from a crisis into a revelation. It suggests a universe where dark matter structures are the rule and luminous galaxies are the rare, glittering exception. The fear is not that the simulations failed, but that they succeeded too well, predicting a hidden cosmos far more populous and dark than we ever dared to imagine. Our Milky Way may not be sailing through an empty sea, but through a dense, invisible archipelago of shadow islands, their silent masses tugging at the stars we can see, their presence felt only in the persistent gap between our digital predictions and the incomplete map written in light. This radical possibility forces us to consider a far more tangible and terrifying form of darkness. If dark matter is not a sea of exotic particles, what if it is a swarm of ancient, hungry shadows? This leads us to a hypothesis that reimagines the very fabric of the cosmos. Some scientists propose that dark matter could be made of primordial black holes. These would not be the black holes we know, born from collapsing massive stars. These would be relics of the universe's first violent second, forged in the unimaginable pressures just after the Big Bang. They could range in size from smaller than an atom to larger than a star, all formed before the first light ever shone. In this scenario, a dark galaxy would not be a diffuse halo of invisible particles. It would be a dense, drifting cloud of these primordial black holes, a gravitational swarm bound together by their own collective mass. The idea is both elegant and frightening. It solves several puzzles at once. These black holes would be dark, they would have mass, and they would clump under gravity, just as dark matter is observed to do. They could even explain some of the mysterious gravitational wave signals we have detected from black hole mergers that seem too heavy to have formed from regular stars. But the fear this hypothesis introduces is profoundly visceral. It would mean our universe is not smoothly filled with an ethereal substance. Instead, it is littered with invisible, planet-disrupting gravitational pitfalls. Imagine the cosmic web not as a gentle lattice but as a minefield. A primordial black hole the mass of a planet, drifting silently through interstellar space, would be utterly undetectable until it passed close to a star or a solar system. Its gravity could wrench comets from their orbits, subtly alter the paths of planets over eons, or even tear apart a star that ventured too close. A dark galaxy composed of millions or billions of these objects would be a region of space so gravitationally chaotic that no stable solar system could likely exist within it. It would be a true zone of danger, a cosmic void where the darkness itself has a fierce, crushing grip. The quest to find evidence for these black hole dark galaxies is a hunt for ghosts with gravity. Astronomers search for the occasional telltale flicker of a distant star, its light momentarily magnified by the gravitational lens of a lone, drifting primordial black hole passing in front of it. Finding enough of these events could map the hidden population. The fear is not just academic. If this hypothesis is true, then the peaceful void between the stars is an illusion. We are sailing through a sea filled with ancient, invisible wreckage from creation itself, each piece a silent testament to the universe's violent birth and a potential hazard on an unimaginable scale. The silence of a dark galaxy might not be absolute. It could crackle with the most powerful, mysterious radio signals in the universe. Fast radio bursts are exactly what their name suggests, brilliant blasts of radio waves that erupt from deep space, each one releasing more energy in a millisecond than our sun does in 80 years. For over a decade, their origin has been a profound puzzle, with theories ranging from the cataclysmic deaths of magnetars to the collisions of neutron stars. But what if some of these cosmic sirens, especially the rare ones that repeat, are not coming from the bright hearts of normal galaxies? What if they are screaming from the dark ones? This is a terrifying possibility. A dark matter-dominated dwarf galaxy provides a uniquely extreme environment. With so much invisible mass and so few stars, the gravitational forces at play are immense and unusual. It could be the perfect cradle for exotic stellar remnants we rarely see, like hypermagnetized neutron stars called magnetars. A magnetar born in such a place, cocooned by an intense dark matter halo, could experience stresses and magnetic field interactions unlike anything in a typical galaxy, potentially triggering the repeated, furious outbursts we detect as repeating fast radio bursts. The fear is not just about finding a source, it is about the nature of the engine itself. If these radio flashes are indeed tied to dark galaxies, then the process generating them is something we have never witnessed directly, a violent, energetic phenomenon playing out in a realm dominated by shadow. It suggests that the empty voids we assume are quiet are actually theaters for some of the most energetic physics in the cosmos, a hidden universe of violence broadcasting in a language of radio waves we are only just beginning to translate. The crackling possibility of fast radio bursts leads us back to a more fundamental and far more frightening kind of energy, The faint, star-poor galaxy Triangulum 2 represents not just a mystery, but a profound crossroads for science. It embodies a specific, electrifying hope that is inextricably tied to a deep-seated fear. The hope is that within the dense, dark hearts of galaxies like this, we might finally see dark matter reveal its true nature through self-destruction. The theory is as elegant as it is violent. What if dark matter particles are their own antimatter opposites? In the normal world, when matter meets antimatter, they annihilate in a flash of pure energy. If the same is true for dark matter, then where these particles are densely packed together, they should occasionally collide and obliterate one another. The aftermath of such an event would not be silent. It would produce a burst of radiation, potentially gamma rays, the most energetic light in the universe. A dark matter-dominated galaxy would be the perfect cosmic furnace for this process, its core so thick with invisible particles that annihilations could happen constantly, creating a faint, telltale glow of high-energy light. This is the hope that by staring at a seemingly empty galaxy like Triangulum 2, we might catch the faint, deadly sparkle of dark matter annihilating itself, giving us our first direct glimpse into the particle physics of the shadow universe. The fear, however, is twofold and paralyzing. The first fear is the fear of silence. If we point our most sensitive telescopes at these dark galaxies and detect nothing, no anomalous gamma-ray signal, no whisper of annihilation, then this beautiful theory could be a dead end. It would mean dark matter particles are not their own antiparticles, forcing us back to the drawing board with even fewer clues. The path to understanding would grow darker, not lighter. But the second fear is even more profound. What if we do detect it? Confirming dark matter annihilation would be a monumental discovery, but it would unveil a universe fundamentally different from the serene cosmos we imagine. It would mean that vast tracts of space, the invisible halos around every galaxy and the dark rivers of the cosmic web, are not quiet, static places. They are active, simmering with invisible particle explosions. Every dark galaxy would be a perpetual engine of self-destruction, a cosmic power plant fueled by the annihilation of its own essence. Our own Milky Way's massive halo would not be a peaceful cloak, but a sphere of constant, silent fireworks. This changes our place in the cosmos on a fundamental level. We would be living inside an immense, invisible reactor. The fear is not of immediate danger, but of a radical reimagining of reality. The universe would be revealed as a place of hidden, relentless violence, where the dominant substance is engaged in a continuous, unseen war with itself. Triangulum 2 and galaxies like it stand at the precipice of this revelation. They are the testing grounds for our deepest hopes and our most unsettling fears, silent laboratories where the darkness might finally show us its fiery heart. The silent annihilation within galaxies like Triangulum 2 hints at a dark, energetic heartbeat, but its true power is far more vast and terrifying. This brings us to the ultimate scale of fear, where dark galaxies are not just cosmic curiosities, but the unseen architects of our universe's final fate. The destiny of all existence, every star, every planet, every atom hangs on the precise nature of the darkness we have been exploring. For decades, cosmologists have laid out 3 possible endings for the cosmos, all dictated by a simple tug of war. On one side is the momentum of the Big Bang, still driving space itself to expand. On the other is the collective gravitational pull of all the matter in the universe, trying to pull everything back together. The balance between these two forces determines our cosmic finale, a gradual cold fade into a big freeze, a violent shredding in a big rip, or a catastrophic collapse into a big crunch. And the dominant factor in that gravitational pull is not stars or planets. It is dark matter, the halos around galaxies, the filaments of the cosmic web, the very scaffolding of reality. This invisible mass is the primary brake on the universe's expansion. Our predictions for which fate awaits us are built on measuring the amount and behavior of this dark substance. This is where the existence of dark galaxies and our profound ignorance about them injects a deep existential dread. What if the properties of dark matter within these shadow structures are not what we assume? Our models assume dark matter is cold and slow-moving and that it does not interact with itself. But what if, in the dense cores of dark galaxies, it has a different character? What if it can exchange energy or decay, or possess a strange pressure we have not accounted for? A subtle, widespread property like this, hidden within countless dark galaxies, could rewrite the equation of the universe's fate. Imagine if dark matter over cosmic time gradually lost its gravitational influence. The brakes would weaken, and the expansion could accelerate even faster than we see today, potentially steering us toward a big rip where even atoms are torn apart. Conversely, what if dark matter can clump more efficiently than we think, or if there is far more of it hidden in pure dark galaxies than our surveys suggest? That extra, unseen gravitational glue could eventually halt and reverse the expansion, pulling all of creation back into a fiery singularity, a big crunch. The fear is not of these endings themselves, but of our blindness. We are trying to predict the final chapter of a story while missing entire paragraphs written in invisible ink. Dark galaxies are the keepers of those missing paragraphs. Their hidden masses, their unknown physics, their sheer numbers, they hold the variables that could tilt the universe toward one destiny or another. The silent, shadowy archipelago we have been mapping is not just a cosmic sideshow. It is the jury that will decide the fate of everything. Our deepest scientific fear is that the ultimate answer is already written, not in the glittering stars, but in the profound and silent darkness between them. Our universe's fate may be written in darkness, but our ability to read that story is bound by the very limits of light itself. The technological fear is a quiet, persistent one, a recognition that our greatest tools are still woefully blind to the deepest shadows. For every dark galaxy we have managed to glimpse, like the ghostly wisp of Dragonfly 44 or the feeble giant Crater 2, there is a haunting question. What if these are just the brightest of the dark? What if they are merely the shallowest shadows cast by objects so utterly faint they dissolve into the infinite background noise of the cosmos? This is the frontier where our ambition crashes against the cold, hard laws of physics. Our window on the universe, from the venerable Hubble Space Telescope to the revolutionary James Webb Space Telescope, is engineered to collect photons, the particles of light. Their power is staggering, allowing us to see the first galaxies forming and to analyze the atmospheres of distant worlds. Yet their fundamental weakness is the same as their strength. They require light to see. An ultra-diffuse galaxy, by its very nature, emits a pathetically small number of photons per square arcsecond of sky. Its light is spread so thin that it falls below the detection threshold of even our most sensitive instruments. It is like trying to spot a single, dimmed light bulb from miles away while staring into the glare of a city. The cosmic background glow, the scattered light from distant stars and nebulae, creates a luminous fog that can completely swallow these faint signals. The James Webb Telescope, with its infrared eyes, can peer through cosmic dust to see further back in time, but it cannot magic photons into existence from an object that emits almost none. The fear is that we have built the most magnificent lanterns, only to realize the darkest caves have no walls to reflect the light back. We may be surrounded by a population of ultra-dark galaxies, objects with even less starlight than the faintest we have found, that are simply invisible to any telescope operating on the principle of collecting electromagnetic radiation. They would be permanent ghosts, their masses perhaps inferred only through the subtlest gravitational tugs on things we can see, but their true forms forever shrouded. This technological limitation locks away answers to fundamental questions. Are dark galaxies the dominant form of structure in the universe? What does the purest, starless dark matter halo look like? The data we need to choose between competing theories of dark matter and galaxy formation might be forever trapped in that unreachable layer of darkness. It forces a humbling admission. Our entire understanding of the cosmos is built on a census of the visible, and we have no guarantee that the visible is representative of the real. We are mapping an island in a fog, unaware if it is a lone outpost or part of a vast, hidden continent. This technological blindness forces a confrontation far deeper than engineering. It touches on a profound philosophical fear, one that has quietly grown with every dark galaxy we have discovered. If the cosmic web is the true architecture of reality, and if dark matter halos outnumber luminous galaxies by thousands to one, then what does that make us? The glittering spirals, the blazing star clusters, the planets and the life upon them might not be the main event. We could be a luminous afterthought, a thin, sparkling veneer painted onto a vast, dark scaffold. This realization injects a powerful dose of cosmic humility, and with it a specific kind of fear. For centuries, humanity placed itself at the center of creation. We have since learned we orbit an average star in the suburbs of an ordinary galaxy. Now we face the possibility that even our galaxy is not the primary structure. It is the decoration, the real substance of the cosmos. Its mass, its gravity, its defining framework is made of something that does not interact with light, does not form complex chemistry, and will never know a sunrise. We are built from the cosmic pollution, the heavy elements forged in stellar furnaces and scattered by violent explosions. Our entire reality, everything we see and touch and are, exists in the thin, rich residue left over after the dark matter did its silent, foundational work. This perspective is both terrifying and awe-inspiring. It suggests that the universe, in its essential nature, is not built for light or life. It is built for gravity and shadow. The conditions that allowed galaxies like ours to shine and planets like ours to form might be a rare and fragile accident within a much darker, simpler, and more dominant order. The philosophical fear is not of being alone, but of being incidental. It asks a haunting question. If the dark matter universe is the true, silent majority, what is the ultimate purpose of our small, bright, noisy corner? The answer for now lies only in our own contemplation. We are the universe's way of observing itself, but we are peering out from a tiny, well-lit room, unaware of the immense dark house that surrounds it. Our philosophical fear of insignificance is a mirror held up to the universe, but the reflection might be telling us we are misreading the very laws of reality. This brings us to the ultimate, most disquieting fear of all. What if the dark galaxies are not evidence of an invisible substance, but a colossal cosmic illusion? What if our foundational theory of gravity, the very framework laid down by Einstein, is subtly incomplete on the vast scales of galaxies? This is not a fringe idea. It is a serious, competing paradigm known as modified Newtonian dynamics, or MUND. Its proposition is terrifying in its simplicity. Perhaps there is no dark matter at all. Instead, the force of gravity itself behaves differently when it becomes incredibly weak, such as in the outer reaches of galaxies or within the diffuse stars of a ghostly galaxy like Dragonfly 44. In our solar system and in laboratory tests, Newton and Einstein's laws work with breathtaking precision. But MUND suggests that in the extreme low acceleration environments found in galactic outskirts, gravity gains a tiny extra kick, a modification that makes stars orbit faster than standard physics predicts. This would explain the rotation curves of spiral galaxies without invoking any unseen mass. It would explain why stars in ultra-diffuse galaxies move at speeds that should tear them apart. The gravitational glue holding them together would not be an invisible halo, but a slight tweak to the law of gravity itself. The fear this idea generates is existential because it threatens to dismantle the entire dark matter edifice we have spent decades constructing. All those mysterious halos, the cosmic web, the annihilations in Triangulum 2, could be phantoms born from a fundamental misunderstanding. The dark galaxies would not be structures of shadow, but natural consequences of a rewritten law of physics. Proponents of MN point to stunning successes. It often predicts the rotation speeds of galaxies from their visible mass alone with remarkable accuracy, something the standard dark matter model struggles to do without carefully tuning the shape of each individual dark halo. The apparent lack of dark matter in galaxies like NGC 1052DF2 becomes not a crisis but an expected outcome under MN rules, yet the fear cuts both ways. For every puzzle MN seems to solve, it creates a new, potentially deeper one. The bullet cluster is its greatest challenge. Remember, in that collision, the gravitational mass, mapped by lensing, cleanly separated from the normal matter. MN must explain how a modification of gravity could somehow leave the bulk of the gravity in a place where most of the visible matter is not. Some MN variants introduce new types of invisible fields to account for this, which to critics begins to look suspiciously like a different flavor of dark matter. The debate is not a polite academic discussion. It is a fierce, fundamental battle for the soul of cosmology. On one side, a universe filled with a mysterious, dominant particle we cannot see. On the other, a universe where our most cherished theory of gravity is wrong. Dark galaxies sit at the heart of this storm. They are the ultimate test subjects. Each new faint, diffuse galaxy discovered is a fresh data point, a new extreme environment where we can ask, does gravity behave as expected or does it subtly shift? The fear is not about which side wins. The fear is that both might be wrong in ways we have not yet conceived. Perhaps dark matter exists, but it interacts in strange ways we have not modeled. Perhaps gravity is modified, but not in the simple way MN proposes. Or perhaps the answer lies in a third, even more radical direction. The true terror is that these silent, shadowy galaxies are holding a secret that could force us to tear up our textbooks and start again from a blank page, admitting that after centuries of discovery, the cosmos still has the power to humble our deepest certainties. The silent galaxies have forced us to stare into an abyss of questions, from the ghostly giant Dragonfly 44 to the feeble, sprawling paradox of Crater 2, from the annihilating heart of Triangulum 2 to the cosmic mirage of HI 122+01. Each shadowy structure has been a lesson in cosmic humility. We have traced the invisible skeleton of our own Milky Way, witnessed the violent proof in the bullet cluster, and dared to imagine a universe whose final fate is written in this very darkness. These 25 dark galaxies are not merely a list of curiosities. They are 25 frontiers, 25 glaring signposts marking the edges of our understanding. They represent the profound truth that most of the universe is not just unknown, but fundamentally unknowable by the light we rely on. The fear they inspire is not of monsters, but of mystery itself, the chilling realization that the cosmos is built on a foundation we cannot see, touch, or yet fully comprehend. So the next time you find yourself beneath a clear night sky, look up, see the glittering band of the Milky Way, the faint smudge of Andromeda, but now know what lies between and within them. Feel the awe, but also that subtle, thrilling fear. You are not just looking at stars, you are gazing into a vast, dark ocean where invisible islands drift in silent multitudes, shaping everything you see while remaining forever hidden. The universe is far stranger, darker, and more wonderful than we ever dreamed. If these cosmic mysteries captivated you, consider subscribing to journey deeper into the shadows with us. And in the comments below, tell us which of these dark galaxies chills you the most. Is it the ghostly giant, the silent annihilator, or the thought of our own galaxy's invisible halo? The conversation about the dark universe is just beginning.